quick solution of a book problem that I suggested that you use for review, just to get, not that it's something on the test will be exactly like this, but just to get an idea of how these problems can vary. So here's a satellite, and we discover that the angle between the vertical, in other words to the center of the Earth, and the horizon, in other words a tangent to the Earth, is 60.276 degrees. And we know how high the satellite is. It's 600 miles high above the Earth. And we want to measure the radius of the Earth. So here's the radius of the Earth, r. Well, the tricky thing here is that this is not one of the sides in the right triangle. So that's the main thing about these kinds of problems, is don't assume that some given length is a side of a right triangle just because you want it to be. In particular, it's not this. That's not how you measure something, how high something is. It's this distance here that's 600. Well, that's okay, because if this is r, then this is r as well. And so r and r plus 600 are going to show up in the triangle. So we're going to have opposite over hypotenuse compared to this angle. That's the opposite, that's the hypotenuse, is equal to the sine of 60.276 degrees. That's something we can solve, and I'll just do it real quickly because I pre-prepared it. That's the equation I just wrote down. Here's the numerical value for sine of 60 plus a little bit. It's a little bit bigger than root 3 over 2. And I just cross-multiplied. I just multiplied out the fraction. R equals this times R plus this times 600. That's the numerical value for that. Then we just bring all the R stuff over. So 1 minus 8.68, etc. times R is 521.05. Simplify that, divide, and the final answer, about 3960, which is really pretty close to the right answer.